Okay, so are you ready? Okay, so let's continue this presentation. So this demo is used for the TCP client. So the CR use as TCP client. This demo, for example, if we use the industrial camera, so if we want to communicate with the robot, so we can use this demo for the communication. So the camera used for the server and the TCP and the CL5 used as the client. So this command should be used like this. Okay, this is our sorry, not this one. I'm sorry. This one is the correct one. I want to show you. I'm sorry. So this is the demo I use for our CL5 with the camera. So the camera should have send some value of the condition, for example SYZ and RX, RY, RZ. So this coordinate system this value. So how do we get this data from the camera? So this is a good demo for the beginner. So we can see that after we set this parameter for this initial, so we do have a function. How do we split the string we get from the camera? So this is a good learning for you. So we can see that. Okay, so in this wide and in this syntax, so the TCP write is used for we send the data to the client. So if the client can receive our data, so it should be 1, 2, 3, 4. And the next is TCP read. This is for receiving the string from the camera. So if the data is not new, so we can see it, we can receive the data. So the next is show how to split the string we receive from the camera. For example, we set table one variable, and we used to get the buffer from the camera. So this print is used to confirm the exact value from the buffer. So in this demo, I used the PART1 to get the data from the camera. For example, if we go to the right position, PART1, and after we get the data from the camera, so we can't go to the right position, the camera calibration the real position. So this is used for this in this phenomena. So PART1 coordinate 1, 2, 3, 4, 5, 6. So this is the real all of the value in one position. So it should be 6 value. This is corresponding to the x, y, z, our x, our y, our z. So after we finish this split and data transfer, after we finish that, we can use the point one directly, but the point one should not be the same as the point one we set in our program. So this point one should be the one after we receiving the string from the power from the camera. So this is the position we want to go. So this demo is used for the camera communicate with the self-drive. So this demo I can send to you after this conference. This is very useful. So you can copy this code and use in your screen directly. Maybe most of this code you do not need to modify it. Okay, this is for the TCP. So for the Modbus, I do have a document to share with you. Okay, let's shift to the right page. This way. Okay, can you see my screen? So this is the document for the Modbus. So this is not the new one because the Modbus we have support the master. We have support master and slave of the Modbus. So we do have the latest version of the Modbus, but this document is in Chinese. So we will send you the English version in the near future. So this document, I just want to show you some of the features and some of the registers or of the Modbus. For example, like the coin and the holding address. So if we want to use our software, not to use like the SD Studio, this programming software, we can use the Modbus, for example, with the PLC, with the HMI. So if we use this device to control our self-drive, so you can use the Modbus communication. So for example, the count from 0 to 5, so it should be coordinating to the command of the robot: start, pause, continue, stop, stop, clear alarm. So if you use the robot or use the PLC, so you can know that this vessel, this current register is very useful in most of our industrial application. So we can use the Modbus. So this is very convenient, very convenient for you to use, and it's easy to understanding. Just need to receive the edge of the signal. So this should be a right edge of the signal. Okay, so this is for the other usage of the register. So let's go to the next. Okay, this is the input register. So we can catch some of the parameter of the robot through this current register. So let's see the description. So we can see that we can catch the position of the server. So the train, for example, the train 1 to the train 6. So we can see that the position of the server 1 the position of the server 6. This is coordinating to the train value of the robot, and this is the speed, and the dock we can read most of the parameter from our robot. So we can see the real-time parameter through this port, this interface. Okay. For the next is used for the angle of the train and the running speed, running position. So this is for the Cartesian coordinate system. So here this parameter is used for the train coordinate system. So we can reach two of the coordinate system of the value. Okay, so for the user-defined holding register, so you can use for reserve some data or transfer some data without external device like the PLC and the HMI. So we can use like that. Okay, this is the what I want to show you about the model bus. We support the master and slave. Okay, let's go to the next. So for the model bus, besides the communication, we do support the expansion of the I/O with our robot. Okay, so can you see my screen? This is the document for the MT400, but this usage of the module is the same usage in our CR. We can use the model bus I/O for expansion. So I can show you, for example, we just skip the MT400. We just see the MT140. So this is a remote I/O, one type of the remote I/O. So we just need to connect to the switch. Use the Ethernet port connect to the switch, and then use the switch port connect to our robot. So we can use this remote model bus this module for the I/O expansion. So for this module, so we support the PNP and the NPN sensor. So we will optimizing the document, and then we can share with you in the near future. So this document, the usage is the same as the MT400. So for example, it should be the same with the different type of the module. So we have a group of input power supply, and then we have a group of output. So for this module, so this output should connect to the power supply of this port, and then this is just an example. So this COM port we connect to the positive input. So if we use the different type of the module, so maybe it should connect to the negative input. So it depends on what type of input. If you use the PMP or use the PMP, so it should be different. We can see it from this description. So for the next, we have a tool to set up the parameter of the module. So it's very easy. So we just need to set the device ID, and the IP of the module, and then some necessary parameter. So that's enough. So after we finish wiring this module to the robot, to the CL controller. So next we need to open our SC Studio, this software. So in this software, it should be our parameter, and this is the menu of the I/O monitor Pro. It should be a menu of this interface. When we click and enter this in this interface, so we can see that we have to add a button in this software on the right drop of this software. So it should have a box and pop out in the screen. So we just need to click yes, and we can after we click yes, we can see there's a setting page of the module. Sorry. Okay, so this one is the demo I use for testing. So we can see all of the parameter we need to set in our software. First is the name. So it is not necessary. You can use different name. For example, we can use 1, 2, 3. That's okay. The most important of the parameter is the ID and the IP address, and we need to select this input address and output address, and the 0 to 1000. 0 is the beginning number of the I/O, and the number on the end is the number of the I/O input. Okay, so after we finish this setting, so we can see that our sorry. Okay, it is not the correct page. So okay, I can tell you the detail about this page. So what is the input address and how do we need to set, and what is the meaning? So for this ID, so it can be repeated, and you cannot use the same in your module. So for example, you have two pieces of the module, so the ID should not be the same. If you set to one, you cannot use one ID one. And for the input address, so it can be repeated, and the address should begin from 101, and the number of the I/O input, it should not be exceed to 1000. And for the number, it should be the actual point of the inputs. For example, if we use the A input in this picture. So for example, this is we have 8 input and we have A output. So we need to set this this value like this. Input value, we set the value to 8, and this output we set this value to 8. So this is what we need to know. Okay, after we finish this wiring, so the last is how to use in the software, how to use in the school program. So it's very easy, just like the GIGO, because this is an remote I/O module, so we can use the I/O directly, like the function of we use in the robot. So I take the example of the M1402, So we have two pieces of the module. Okay, so for the module 1, so the ID is 1, and the module 2, the ID is 2. So it is different. Okay, so next the respectively I/O. So we have set I have told you. So the ID of the module should begin from the 101. We can go to the right page. This one. Please notice that. So we support. So we support this IP address. So the begin of the IP address should be the 101. Okay. So for the second module, so the IP, so it should be from 201. So please notice that if you use the third one, so the IP address should begin from 301. Okay, so the sequence should be 1, 2, 3, 4, 5 to 7. So this is 8 input of our module. Okay, so this is the testing demo for the module. So I just use the function and code in our main program. So the usage is the same with IO in our controller. So it should be the address and the schedule. So for example, the DO we use we open if we turn on the output signal. So the command should be DO and the address and on. So here we use DO 101 and on. Okay, if we turn off the output, so the command should be DO 101 off. Okay, this is the demo. So if you have the module, you can use my demo code directly for testing. Okay, for the next, because I do have many documents to sharing with you, because we know you should be interested in, and your customer should concern about this function. Okay, so one important function with a robot is the teach trajectory. So it's a very useful function in our application. So for in our screen program and terminal, the panel on the terminal of the robot. So we have two methods to create this teach trajectory project. So first, let's begin with the panel. So on our robot, on the terminal, we have the panel. This panel is used for teach trajectory to turn on the function and record and playback. So it's very useful. And we also have this function in our SD Studio. So we can start this teaching trajectory, this function in our software. We just need to click start teach. So we can move our we can hold our arms and move to every trajectory you want, and then after we finish, we just need to click stop teach, and then we can get a record project file here. So you can see it in my screen. So it should be two project file here. So for the first one, this file is created by our software, by our SD Studio. So the second one is created by our terminal panel. So a process of the project is the teaching trajectory. So we have two methods to create. Okay, so in our screen, in our SD Studio, in the screen program, so we can use this function to code this teach trajectory, this project file in our program. So the first line, the JSON file is this is the name of the trajectory file. So for example, if we use the first line of the project, and this project we can rename here. we can choose the project and click the little name and use the wrong one we want to change. So we can change the name. For example, we can rename this project to one. So in our Scrum program, we should here we should use one dog attraction. It should be the name. Okay. So the P1 is the stop post, and the P2 is the first one of the trajectory project. So we just need to local two of this parameter, and then Y22 this is used for repeat our project. So we can set this is the first one of the trajectory project. We need to set the first one, and then this is the path of the reference, the trajectory project. So this is the file. Okay, and this in this command we have to set the ratio of the velocity and the constants of the trajectory appearance. If we choose one, so it means it is constant. Okay, so this is very useful. So most of customers ask how to use our robot easily, and if someone do not have the basic of the robot, so how do you use our robot? So this function is very useful for the beginner who have no basic of the robot. So this is very important, very useful. We just need to record this trajectory and then copy the code to the Scrum program. So that's enough. Okay, so next I do have some experience with you how to set some parameter in the Scrum program. Okay, so this page is about how to set different speed in our Scrum program. So in many applications in the industrial application. So we need to set different speed in different motion. So how to set this speed? So this is the demo. So for example, this variable this value we set 20, 40, and 60. I set this to the different speed, and then I use in my program. So for example, I use before this move chain, I use this speed before this move chain. So I set the speed to 20%, and this command should run under the speed of 20%. So and then next I use this code, and the speed I use 10%. So it is 20%. And the next I use the move, and the speed is 40%. So different motion in our program. So we can use like this. Okay, so the next page is used for set up the collision level in our Scrum program. So this is the sample. First, we need to control the end load. So we need to load switch the schedule. So we can see that we need to set load the schedule, and then we need to set the current load. So this is for change the collision level. So we do have the command in the Scrum program. Okay, so I think this is it's very useful for us and for our for the beginner. So I think this can help you in your application and your work. So that's all I want to share with you today. So thank you for your listening. So the last part we should be Q&A. So I will unmute all of your mic. So if you have any questions, we can talk about here. Okay, please wait. Okay, so can you all unmute your mic? Okay, thank you.
Thank you.
So you can unmute your mic and can talk here.
就是他问了，然后那个问题呢，其实问给 Anders， 他好像问这个。
Hi everyone, can you hear me?
Set up from hardware.
Hi everyone, can you hear me? Okay, so you can ask me your questions here.
Hello.
Hello.
Can you hear me?
Yes.
Yeah. So I would. Hello. Yeah. My name is Andy. I would like to know what is the maximum operating hours for the DOBOT, specifically CR5. Let's say if we run it in production line, does it need to be periodically reboot or shut down for maintenance? Like let's say if we run the CR5 in 24/7, 24 hours in 7 days, do we need like a time off or we need to shut down the robot?
Sorry, can you repeat? I'm sorry.
Yeah, sure. Okay. So for the CR robot, let's say if we run it in production line, like in 24 hours in 7 days, do we like need to periodically shut down the robot? Like maybe just because of the hardware, it maybe cannot stand high heat.
Okay, so you can run for 24 hours, no problem. But it depends on the environment of your industrial application. On your you, you need to consider that it should not be the high temperature than our requirement temperature. Okay, so for the time it is no problem. Or for no matter for 24 hours or 48 hours.
Okay, understood.
Okay.
Yeah. So apart from that, I have another question regarding the maintenance part. Is there any periodical maintenance, like maybe in 1 month, do we need to inspect for any general maintenance? Do we need to do some kind of that service?
Okay, so for your question, I think we don't need to do that. So our cobot this is type of cobot, so it's not the traditional industrial robot. So that's different. So as you mentioned for the maintenance, so I think no need to do more for this robot. Just for the clean and the service and notice the temperature and the environment of the robot. This match up to our requirement environment. So that's enough.
Okay, understood. Thank you.
You're welcome. Okay, so another one have the question. So if it is not convenient for you to speak with me, so we can type by text in the checking post. So that's all right. It's okay for me. Okay, so for the hand Tai Chen, hello. So for your question, it is possible to send a post request with the sales series. So do you want to catch the poster of the robot for the real time feedback?
Yep. Post a HTTP request.
Okay, so yes, we can do that. We can get the real feedback. Okay, so for this question, I just want to show you a document about the TCP protocol. So for the secondary development, so in the near future, so maybe by the end of this month, we will support the TCP protocol. So I can share you a document. Okay.
Oh, okay.
Okay, so that you can know the actual usage. Okay, can you see my screen? So this is a document about the TCP protocol. So Okay, I do not want to full screen for this document. Please wait. Okay, so this is a document about the TCP protocol. So for this dashboard, so we support many commands in like we use in the Scrum program. So we can see it in the lab area of the menu. You can see that we support many basic of the command in the Scrum program. So like the motion and the IO and other else. So second is the real-time feedback. So I think that's what you want to use. So I think this server client. This is for receiving the client parameter from the robot. You can see that this you can use like this one. This is a server P. This is for the position. This is for used for the under the partition or coordinate system. So for this is used for the client coordinate system. And then this is for the move client move line. And this is for the client movement. This is for the jump. So we can all of this command we can use the TCP protocol to get the real-time feedback. So we support this port. So we can use this TCP protocol. So without our programming software like the SC Studio, we do not need to use the software, and we can realize controlling our robot use this protocol. Okay. Hello.
Yeah. Okay. Thank you.
Okay. So to understand what is the meaning of my speech?
Yep. You're saying that using TCP/IP protocol to communicate instead of using the software.
Yes. So this TCP protocol will be released by the end of the month, this month. So this is the document. So if you need, you can ask our sales manager, or you can ask me directly. So I can send you this document. No problem.
Okay.
Okay. Thank you.
Thank you.
You're welcome.
Hello, Mr. Eric. Yeah, sorry, this is me again. I have a question, yeah, regarding the software SDK. So, in the earlier of the presentation, your colleague mentioned that we actually have Python and C# support for the SDK part. So, may I know if we can have a look at the documentation, or can you provide us, yeah, the documentation?
Have you downloaded the SDK from our official website?
Not yet.
Not yet.
Yeah.
Okay. So we have the interface document in, and we in the compressed project in the SDK. So you can install this this compressed file, and then you can see this document. And we do have the limit this PDF document. So this we provide the instruction for you to use the SDK. So no matter you use the C#, Python, or other else, so we do have the instruction for you.
Mm.
So
Thank
maybe
you.
you need to get one SDK file first, so that you can know. We have many demo in this code, so you can know that exactly if you get this SDK. Okay.
Mm. Okay, that's great. That's great. Yeah.
Okay. Thank you.
Okay.
Okay. So anyone else have the question?
Hello.
Hello. Have your hand up. Hello, I can hear you. Please continue. Okay, so I think I can show you the document about the safe skin. So because the serials we provide the version with the safe skin, so we can share the document with you. So this is the safe skin. This is the document. So if you have the robot with the safe skin, so you can have a try. So the safe skin, it should be covered with the trend 4, trend 5, trend 6. You can see that in this picture. So that's what the safe skin looks like in this picture. Okay, let's just go to the part of the program. So for the safe skin, we can't install the plugin in our tablet because we provide the app for you. So you can't install in your tablet, and then you can find the Turbo Plus, and then there should be an electrical skin on the app. You need to install this plugin first, and you can see this interface should be like this. We have a switch for you to turn on this function or turn off. Okay, so we can also set some advanced parameters in this interface. For example, you can see it here. So the detection distance we can set in this interface. And on the right, this is for the setting avoid parameters. This is for the optical avoidance function. We can set some parameter like the speed. Okay, so when you finish the setting up of the plugin, so we can't use this step screen function in the screen program. So, for example, if we want to turn on the step screen, we can use this command here. 0 is turned off and 1 corresponding to are open. And the last one is the obstacle or avoid. This command is used for you. If you turn on this function, the robot will go around the object and will not hit to the object. So this is for the obstacle or avoid function. And the 0 is the turn on, turn off, and 1 is for turn on. Okay, so do you have any question to ask me about the step screen? Okay, if not, so I do have two documents to share with you. So just for about the collision hole for the robot and the workbench for the robot, I can share with you. Just 5 minutes. So this is showing about the workbench. So if you do not have the right one, so we can provide this page to you. So this should be the dimension of the workbench. So and this is the tooling hole or for the platform. Okay, and the last one is the calibration hole or paste paper. So let me show you. So we can see that we have 4 screws. You need to drill hole for the fixing of the robot. So the dimension is like that. You can see that we have four hole to fixing the robot. So this diameter should be 9 millimeter. So when you receive the robot, you can cut this paper in the box. So this is the last one I want to show you and share with you. Okay, so any other one have their questions? Okay, so if not, so I'm glad to tell you that we will finish today's training. So thank you for all of you. So and thank you for your time. Okay, so let's finish today's training. So thank you so much. Thank you. See you. See you. Bye bye.
Thank you.